Hello, NRK Academy presents Master Advanced Physics, and this is for all the top exams like IIT or NEET or AIMS. And this is the first video where we are covering kinematics. So this is the kinematics 1. So we have the first concept called statics, kinematics and dynamics. Let's try to understand these fundamental terms: statics, kinematics and dynamics. It's a very simple concept. Statics is the study of bodies when they are stationary, when not in motion. So you study about how they behave in terms of its behavior when it is not in motion. That we'll cover in statics. And what we're going to cover in this video is kinematics. Now the kinematics is, kine means motion, study of bodies when in motion, but we do not consider the forces or the causes of the motion. We do not ask whether there was a force and how much the force was. Then what do we study? We only describe it. We only describe it. We only say what is happening, not why it is happening. When we go into the first three videos, we'll understand completely that it is a description of motion, not why a motion is happening. And the next concept is dynamics. Dynamics takes care of actually the causes of motion. The study of motion of bodies while considering the causes of the motion, the forces. So once we are clear, why are we trying to understand this? Because now we have covered all the types of subjects which come under bodies. Rigid bodies. Rigid bodies means they don't expand with some application of force, and that would be actually elasticity, which is not covered here. The next concept is rest and motion. So what is the meaning of rest? Rest is simply rest, which means with the frame of reference. Like suppose I decide that this room is at rest. I decide it, I consider it, I fix it. Then with respect to that room, the walls of the room, a certain body is not changing its position with respect to time. So suppose you have a ball in a room and it is not moving, and I consider the room at rest, the room, the walls, then the body is at rest with respect to the walls. This is called a frame of reference, which we'll see when we come to relative motion. But remember, the wall is also moving because Earth is moving and the solar system is moving. Everything is moving in the whole universe, which is why we have to think of rest with respect to a frame of reference which we decide is stationary. So this can happen even in a train. Suppose a train is moving very smoothly and you are keeping that ball in a train. That ball with respect to the train is not moving, though with respect to the ground it might be moving. So this is a very interesting concept. We will see that concept in further detail later. And what is the opposite of that? Motion. So if it moves with respect to a fixed frame of reference. So very simply put, if there's a ball in a room and the room is you have decided to keep the room at rest, then if the ball is changing its position with respect to the room, then it is in motion. And what is motion in one dimension? It is going in a straight line. What is motion in two dimensions? It is covering the area, like it is going in a curve. And what is motion in three dimensions? It is flying in the room. As simple as that. Now we come to the next concept, distance and displacement. Distance is the actual distance traveled by a body, and displacement is the shortest straight line distance covered by a body. So distance is, suppose the body is going in a kind of curve, in a random curve, then the whole curve, the whole distance, actual distance traveled by the body is given a specific name in physics called distance. But displacement is, you take the initial point, let's say A, take the final point, let's say B, join A and B, that would be displacement. No matter how the body traveled, the shortest or the straight line distance from the initial point to the final point covered by the body is called displacement. Now we come to speed and velocity. Now what we see in real life is speed. You can see the two bodies are going faster. So suppose one body goes at 10 meters in 5 seconds and another body goes 10 meters in, let's say, 3 seconds. Obviously the first body has gone slower. The second body has gone faster. How do you exactly measure it? And which distance do you take, distance or displacement? You take both. If you take distance, then speed is distance covered in 1 second. If you take velocity, there's a specific word, then we do not consider distance, we consider displacement covered in 1 second. So speed is d by t, d here is distance, and velocity is s. S here is not speed but displacement divided by time. So in 5 seconds, if the body has traveled distance of 10 meters, in 1 second it has traveled 2 meters. How do we write it? 2 meters per second. If a body has displaced, if this had a displacement of 10 meters in 5 seconds, then in 1 second it is 2 meters. Now we come to average speed, but normally in real life, bodies change their speed, they cover different distances at different times. If you're going on a bike on a road, straight line also, then we take the total distance by total time. Only that will give the average speed. So average speed is not the actual speed, because the body might have been changing the speed every 2 seconds or every 1 second. Sometimes it might have stopped also. So total distance by total time is average speed. And what is instantaneous speed? At one point, suppose you are going in a car and you are looking at your speedometer. At that point of time, what is the speedometer showing would be instantaneous speed, and speed here would be the distance we are considering here. Next we come to average velocity and instantaneous velocity. The average velocity is total, not distance, but displacement by total time, and instantaneous velocity is exactly velocity at that point or moment of time. Now we come to a uniform motion in a straight line. Uniform means constant. The velocity is not changing. So we have two graphs here, position time graph. So if the velocity is not changing, as you can see, it will be a slanted straight line, because at every second it will go on increasing. The distance will be increasing. Position time. So in 1 second, 2 meters. In 2 seconds, 4 meters. In 3 seconds, 6 meters. Every second it has increased its speed by 2 meters. So it will be a curved straight line. What will the velocity time graph be? It will be a horizontal line. It will be a horizontal line, and it will be not a slanted line, because in 1 second same velocity, 2 seconds same velocity, 3 seconds same velocity. So these are the fundamental concepts in our video. That completes our first video. We're going to give you short videos in which you will get the concepts with total clarity to crack IIT and NEET and such exams. So again, we revise. Statics is the study of body with not in motion. Kinematics is the study of bodies without considering the causes. Dynamics is the study of bodies while considering the forces and the causes. Rest is rest. Motion is motion with respect to something you decided which is at rest. Motion in one dimension is straight line motion. Motion in 2 dimensions is curved motion on a surface. Motion in 3 dimensions is in the volume. It is in the air. Distance and displacement. Distance is the actual distance. Displacement is the shortest straight line. Speed is equal to d by t. Velocity is equal to s by t. Average speed is total distance by total time. Once you understand these concepts, problems become very easy. Average velocity is total displacement by total time. Position time graph is slanted. Velocity time graph is straight line, horizontal line, because at every second the velocity doesn't change. Thank you so much.